For decades, Uranus has been one of the most enigmatic planets in our solar system, shrouded in mystery, its secrets locked beneath swirling clouds of icy gas. But now, in a groundbreaking discovery that has sent shockwaves through the scientific community, the legendary Hubble Space Telescope has cracked one of its biggest puzzles: the planet's true rotation rate. And what it found will leave you stunned. Imagine a world where a day is not what it seems. A planet spinning so strangely that its magnetic field wobbles like a top about to fall. A place where auroras dance in chaotic, unpredictable patterns, defying everything we know about planetary behavior. This is Uranus, a cosmic oddball that has baffled astronomers for generations. But thanks to Hubble's relentless gaze, we now have answers sharper than ever before. An international team of astronomers has just achieved the impossible, measuring Uranus's rotation with mind-blowing precision, 1,000 times more accurate than ever before. How? By turning the planet's own auroras into a cosmic clock. These mesmerizing light shows, generated by charged particles spiraling into Uranus's atmosphere, hold the key to unlocking its spin. And after analyzing over a decade of Hubble's ultraviolet observations, the results are in. Uranus completes a full rotation in 17 hours, 14 minutes, and 52 seconds. But here's the twist. This new measurement shatters previous estimates. NASA's Voyager 2, the only spacecraft to ever visit Uranus, had it wrong by 28 seconds. That might not sound like much, but in the world of planetary science, it's a game changer. A few seconds can throw off entire models, making it impossible to track the planet's magnetic field over time. Now, with Hubble's razor-sharp data, scientists finally have the ultimate reference point, a celestial GPS to navigate Uranus's chaotic magnetosphere. Why does this matter? Because Uranus is unlike any other planet we know. Its magnetic field is a true freak of nature, tilted at a jaw-dropping 59 degrees from its axis and wildly off-center. This bizarre setup creates auroras that flicker and shift in ways no one can fully predict. Earth, Jupiter, and Saturn have orderly, symmetrical light shows. Uranus, it's like a cosmic disco gone rogue. But Hubble's relentless monitoring has cut through the chaos. By tracking the aurora's movements like a celestial stopwatch, researchers have not only pinned down the planet's spin, but also opened the door to something even bigger: a future mission to Uranus. The Planetary Science Decadal Survey has already flagged Uranus as a top priority, with plans for an orbiter and probe in the works. And thanks to this discovery, scientists now have the precision they need to make that mission a reality. Think about it. This is Hubble, doing what it does best. Decades after its launch, it's still rewriting textbooks, still pushing the boundaries of what we know. While newer telescopes grab headlines, Hubble remains the undisputed champion of long-term cosmic surveillance. Without its unwavering watch, this breakthrough would have been impossible. So what's next? With Uranus's rotation finally nailed down, astronomers can start piecing together the planet's deepest secrets: how its interior flows, why its magnetic field is so twisted, and what drives its violent storms. Every new finding peels back another layer of this icy giant's mysteries. And as plans for a dedicated Uranus mission heat up, one thing is certain: the best is yet to come. This is more than just a number, it's a revelation, a leap forward in our quest to understand the solar system's most misunderstood planet. And it's all thanks to Hubble, the telescope that refuses to quit, the silent sentinel of the cosmos, still delivering shocks and awe after all these years. The universe is full of surprises, and Uranus, it's just getting started. For centuries, Uranus has taunted astronomers with its secrets, a pale blue enigma spinning on its side, its atmosphere a tempest of frozen methane and hydrogen, its very nature defying explanation. But now, in a revelation that has rewritten planetary science overnight, the Hubble Space Telescope has delivered a bombshell discovery, the most precise measurement of Uranus's rotation ever achieved. And what it reveals changes everything we thought we knew about this distant ice giant. Picture a planet where the rules of physics seem to bend, where magnetic poles wander like lost compass needles, where auroras flicker in erratic bursts, defying prediction. This isn't science fiction. This is Uranus, a world so bizarre that even seasoned astronomers struggle to explain its behavior. But Hubble, armed with decades of data and cutting-edge techniques, has finally pierced the veil. By turning the planet's own auroras into a cosmic metronome, scientists have clocked its spin with staggering accuracy. 17 hours, 14 minutes, and 52 seconds per rotation. But here's where it gets mind-blowing. This isn't just a minor adjustment, it's a correction that upends decades of assumptions. Previous estimates, based on Voyager 2's fleeting 1986 flyby, were off by nearly half a minute. In the high-stakes world of planetary dynamics, that's an eternity. Imagine trying to navigate Earth with a map that's subtly wrong. Every calculation would spiral into chaos. That's exactly what's been happening with Uranus. Until now, the implications are seismic. Uranus's magnetic field isn't just tilted, it's a drunken tumble through space, offset from the planet's core by a third of its radius. This bizarre geometry creates auroras that don't circle the poles like Earth's, but instead flare in chaotic, shifting ovals. For years, tracking these auroras was like trying to predict lightning strikes. But Hubble's relentless observations, spanning solar cycles, seasonal shifts, and planetary wobbles, have finally decoded the pattern. And the timing couldn't be more perfect. NASA and ESA are now racing toward a flagship mission to Uranus, with launch proposals gaining unprecedented momentum. Hubble's precision measurements provide the bedrock for this journey, offering mission planners the celestial coordinates they'll need to navigate the planet's twisted magnetosphere. Without this data, any spacecraft venturing there would be flying blind. But the surprises don't stop there. Buried in Hubble's findings are clues to Uranus's deepest mysteries, why its atmosphere blasts 500 miles per hour winds. Despite its weak sunlight, why its rings pulse with strange vibrations, and whether sloshing oceans of supersonic water lurk beneath its clouds. Some scientists even speculate that Uranus's off-kilter spin might hide the scars of a chain cataclysmic collision. A primordial impact so violent it knocked the planet on its side. This is Hubble at its finest, not just a telescope, but a time machine. The same instrument that once captured the birth of stars is now unraveling the dynamics of a world 1.8 billion miles away. And as next-generation telescopes like the James Webb Space Telescope turn their gaze toward Uranus, Hubble's data will be the Rosetta Stone that unlocks their discoveries. The message is clear. Uranus is no longer the forgotten giant. It's a planetary laboratory, a window into the chaos of early solar systems, and perhaps the key to understanding how exotic worlds evolve. With Hubble's latest triumph, we're not just solving a puzzle. We're stepping into a new era of exploration. The ice giant's secrets are finally within reach, and the cosmos will never look the same again. The clock is ticking on one of the solar system's greatest mysteries, and with each passing second, Uranus reveals just how alien a world can be. Hidden beneath its serene blue haze lies a planetary engine unlike any other, where the very fabric of space-time seems to warp under extreme forces. Now, thanks to Hubble's razor-sharp vision, we're witnessing the impossible, a planet that shouldn't exist according to conventional physics, yet spins defiantly in our cosmic backyard. Groundbreaking new analysis of Hubble's ultraviolet data has uncovered something even more startling. Uranus's rotation isn't constant. The planet's upper atmosphere is locked in a violent tug-of-war with its interior, creating measurable fluctuations in its spin rate. This discovery shatters the long-held belief that gas giants rotate as solid bodies, revealing instead a complex layered dance of forces that has left astrophysicists reeling. The implications? We may need to rewrite our understanding of how all giant planets evolve. The auroras themselves tell a story of cosmic violence. Unlike Earth's predictable northern lights, Uranus's displays erupt in sudden, explosive bursts, some lasting mere minutes before vanishing without trace. Hubble's sensitive instruments have detected ultraviolet flares so intense they briefly outshine the planet itself, powered by a magnetic field that contorts and snaps like an overstressed rubber band. These aren't just light shows, they're the death throes of charged particles, being shredded by some of the most extreme magnetic forces in our solar system. Deep beneath these atmospheric fireworks, something even stranger is happening. Latest computer models suggest Uranus's interior may contain exotic states of matter never seen on Earth, a supersonic soup where water molecules break apart into a bizarre lattice of oxygen ions swimming in a sea of hydrogen. This could explain the planet's bizarre thermal emissions, which defy all predictions by being virtually non-existent. While Jupiter and Saturn pump out heat from their cores like cosmic furnaces, Uranus runs cold, a thermodynamic paradox that has puzzled scientists since Voyager 2's flyby. The timing of these discoveries couldn't be more critical. With NASA's Uranus Orbiter and Probe mission now moving from concept to concrete planning, every new finding from Hubble is shaping humanity's first dedicated visit to this ice giant. Engineers are already adapting spacecraft designs to account for the newly measured rotation, while mission planners use the refined magnetic field maps to plot safe trajectories through Uranus's radiation belts, regions so intense they could fry unshielded electronics in hours. Perhaps most astonishing is what this means for our search for life beyond Earth. Uranus's largest moons, Miranda with its sheer 20-kilometer cliffs and ocean-harboring Titania, now emerge as prime candidates in the hunt for extraterrestrial biology. The precise rotation data allows scientists to calculate tidal forces with unprecedented accuracy, revealing that these frozen worlds may experience far more internal heating than previously thought. Suddenly, the Uranian system looks less like a frozen wasteland and more like a potential oasis in the outer solar system. As Hubble continues its watch, each new observation peels back another layer of this cosmic onion. The telescope's longevity has become its superpower. No other instrument has monitored Uranus across multiple solar cycles, watching as the planet's atmosphere responds to the sun's changing moods. This long-term perspective is revealing patterns no short-term mission could ever detect, proving that some cosmic mysteries can only be solved with patience spanning decades. The countdown has begun. With every rotation Uranus makes, we move closer to understanding its secrets. And when our spacecraft finally arrives in the 2040s, it won't be visiting an alien world. Thanks to Hubble, it will be meeting an old friend whose face we've finally learned to read. The age of Uranus exploration is dawning, and it promises revelations that will echo through the halls of science for generations to come. The cosmic dance of Uranus continues to astonish as new revelations emerge from Hubble's unprecedented observations. This ice giant harbors secrets that challenge our fundamental understanding of planetary physics, where normal rules don't apply, and every discovery raises more tantalizing questions. The latest findings reveal a world in constant turmoil, its very rotation pulsing with hidden rhythms that speak to the violent forces churning beneath its serene exterior. Cutting-edge analysis of Hubble's data has uncovered something revolutionary. Uranus's magnetic field doesn't just wobble, it actually breathes. The planet's magnetosphere expands and contracts in regular cycles, pulsing like a living thing as it interacts with the solar wind. These rhythmic oscillations create electromagnetic shock waves that ripple through the Uranian system, potentially explaining the mysterious hotspots detected in its upper atmosphere. Regions hundreds of degrees warmer than their surroundings, despite receiving virtually no sunlight. The implications are staggering. Scientists now believe Uranus may possess a previously unknown form of atmospheric circulation, a vertical heat engine powered by these magnetic pulsations that transports energy from the interior to the upper atmosphere against all conventional models. This could finally explain the planet's bizarre thermal signature and why its weather systems behave so differently from other gas giants. Imagine hurricanes that form at the poles instead of the equator, or jet streams that appear and disappear seemingly at random. This is the atmospheric chaos Hubble is helping us decode. Even more extraordinary are the new hints about Uranus's interior structure. Advanced spectroscopic analysis suggests the planet may contain vast reservoirs of exotic ices, not just water, but mixtures of ammonia and methane under such extreme pressures that they form entirely new states of matter. Some researchers speculate these could include ionic ice, a crystalline form where electrons move freely through a lattice of atomic nuclei, creating a material that's both solid and conductive. If confirmed, this would represent an entirely new class of planetary material never before observed in nature. The planet's rings tell their own astonishing story. Hubble's sharp vision has detected subtle ripples and waves propagating through the ring system, the gravitational fingerprints of unseen moons, and possibly even the first evidence of moonlets, tiny moonlets that could be the building blocks of larger satellites. These findings suggest Uranus's rings are far more dynamic than Saturn's, changing shape and structure on timescales of just years rather than millennia. As we stand on the brink of a new era in planetary exploration, these discoveries take on even greater significance. The precise rotation measurements are proving invaluable for mission planners designing the Uranus orbiter's trajectory, allowing them to pinpoint gravity assists that could shave years off the journey time. Engineers are now developing new types of radiation-hardened instruments, specifically to study Uranus's extreme magnetic environment, inspired by Hubble's revelations about its unique properties. Perhaps most exciting is how these findings are reshaping our understanding of exoplanets. With thousands of ice giants discovered orbiting other stars, Uranus has become the Rosetta Stone for interpreting these distant worlds. Its bizarre properties, once thought to be anomalies, may actually be the norm for ice giants throughout the galaxy. This realization is forcing a complete rethink of planetary formation theories, suggesting our solar system's architecture might be far more unusual than we ever imagined. Hubble's legacy continues to grow with each new Uranian revelation. What began as a simple measurement of rotation has blossomed into a wholesale reimagining of an entire class of planets. As the telescope keeps watching, and as new missions prepare to journey to this enigmatic world, one thing becomes increasingly clear. Uranus isn't just another planet. It's a cosmic laboratory where the most extreme physics in our solar system plays out daily, and Hubble has given us a front-row seat to the show. The greatest discoveries may still be waiting, hidden in the flickering auroras and swirling clouds of this most mysterious of the worlds. The deeper we peer into Uranus's mysteries, the more extraordinary the revelations become. Hubble's latest findings have torn up the planetary science playbook, exposing phenomena so bizarre they defy conventional explanation. This isn't just about rotation, it's about uncovering a world where the laws of physics seem rewritten at every turn. New analysis reveals Uranus's magnetosphere isn't just tilted, it's fundamentally broken. Unlike Earth's stable magnetic bubble, Uranus's field lines twist and snap like overstretched rubber bands, creating electromagnetic tsunamis that ripple across the planet. These disruptions generate auroras that don't just glow, they explode in violent bursts of X-ray radiation, something never seen on any other planet. Hubble's detectors have clocked these eruptions at energies comparable to solar flares, suggesting Uranus's magnetic field is somehow tapping into cosmic particle accelerators we don't yet understand. While Jupiter's great red spot slowly fades, Uranus's atmosphere is staging a meteorological rebellion. Hubble's sharp vision has caught monstrous storms erupting in the planet's polar regions, hurricanes larger than Earth that materialize in weeks, only to vanish without trace. Even more perplexing, these tempests rotate backward compared to the planet's spin, powered by atmospheric currents that plunge hundreds of kilometers downward into the icy depths. Scientists suspect these represent a completely new class of planetary weather system, one where the rules of fluid dynamics operate in reverse. Beneath the chaos lies perhaps the most jaw-dropping discovery of all. Advanced modeling of Hubble's atmospheric data suggests Uranus's interior may be creating something straight out of science fiction. Diamond rain. At the crushing pressures found 5,000 miles below the cloud tops, methane molecules are being torn apart, their carbon atoms compressed into crystalline structures that fall like glittering hail through layers of superionic water. This isn't theoretical. Recent laboratory experiments using high-powered lasers have recreated the conditions, proving such diamond storms are physically possible. Hubble's extended watch has also turned up something extraordinary about Uranus's moons. Miranda, the smallest of the major satellites, shows evidence of recent geological activity, impossible for a body just 290 miles across. Its surface is a Frankenstein's monster of terrains, with cliffs towering 12 miles high, proportionally deeper than Earth's Grand Canyon, and valleys that suggest the entire moon was torn apart and reassembled multiple times. The only explanation? Uranus's gravitational field is so chaotic, it periodically rips its own moons to pieces, then lets them reform. a cosmic demolition derby happening right in our solar system. With every new Hubble observation, the case for a Uranus mission grows stronger. The upcoming decadal survey is expected to greenlight a flagship orbiter, with concepts including atmospheric probes designed to survive the diamond rain, and submarines theoretically capable of navigating the hypothesized superionic oceans. Engineers are now racing to develop materials that can withstand conditions where temperatures swing from negative 370 degrees Fahrenheit to over 8,000 degrees Fahrenheit in mere kilometers, while pressures exceed 5 million times Earth's surface level. Perhaps most significantly, Uranus is proving to be the key to understanding the thousands of mini-Neptunes discovered orbiting other stars. These enigmatic worlds, which dominate the galactic planetary census, may all operate by Uranian rules, with lopsided magnetic fields, diamond-rich interiors, and weather systems that make no sense by Earth standards. Hubble's work isn't just exploring one planet. It's providing the decoder ring for an entire class of worlds across the galaxy. As the data keeps pouring in, one truth becomes undeniable. Uranus isn't the boring ice ball we once thought. It's a laboratory of extreme physics, a cosmic freak challenging everything we know about planetary science. And thanks to Hubble's unblinking eye, we're finally starting to understand its alien language, one shocking discovery at a time. The revolution in our understanding of ice giants has only just begun. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Don't forget to check out our playlist for more incredible space content. Until next time, keep looking up